Today's theme, chemical composition of soil. Bugungi taqrib to'proqning ximiyalik quromi. Plan of the lecture. Ders joshlari. 1. Chemical elements of soil. Birinchisi, to'proqning ximiyalik elementlari. 2. Chemical composition of soil and soil forming rocks. Ikkinchi, bu to'proqning ximiyalik quromi yana to'proq qurovchi jinslar. 3. Forms of compound of chemical elements. Uchinchisi, bu quromdagi turlar yana ximiyalik elementlar. The soil consists of mineral organic and organic mineral substances. According to its chemical composition, it differs significantly from the initial soil forming rocks. The main feature of the chemical composition of soil is the organic substances, including humus, the variety of form of compound, and the volatility in the dynamism of the composition in time are present in it. Almost all chemical elements were found in the soil, but correspondingly in various quantities. The average figures showing the content of individual elements in the lithosphere and soils is the suggestion of academician Tersman began to be called Clark's in the bracket in honor of the American scientist, geochemist Clark, who for the first time in 1889 determined the average composition of the Earth's crust. The study of soil from a geochemical point of view was begun in 1911. Vernadsky. The relative content of individual chemical elements in the soil and the lithosphere varies widely. In the bracket table 9. Table 9 content in the bracket and weight percent of chemical elements in the lithosphere and soil in the bracket according to Vinogradov 1950. Element lithosphere. Soil element lithosphere soil. Oxygen 47.2, 49.0, etc. Silicium, aluminum, ferrum, etc. The lithosphere, as can be seen from the table, almost half consists of oxygen, in the bracket 47%, more than a quarter of the silica, in the bracket 27%, followed by aluminium, in the bracket 8, 0.8%, iron in the bracket 5%, calcium, sodium, potassium, magnesium in the bracket up to 2-3% each. 5 of these chemical elements make up the bulk of the lithosphere, more than 99%. On the share of such important elements of plant nutrition as carbon, nitrogen, sulfur, phosphorus, for tenths and even hundredths of a percent. Even less in the earth's crust contains as the element necessary for the life of plants, the so-called microelements. Since the mineral part of the soil caused by the chemical composition of the rocks of the lithosphere, there are similarities between them relative to the content of the chemical elements. As in the lithosphere, oxygen, silica, aluminium, iron, etc. take the first place in the soil. However, in the soil, compared with the lithosphere, there are 20 times more carbon and 10 times more nitrogen. The accumulation of the element in the soil is associated with the vital activity of organisms. The chemical composition of soil and soil-forming rock is determined from the data of gross chemical analysis. In loose weathering as a rule, the total content of silica is higher than in magmatic rocks, but its content varies greatly depending on the genetic type of the soil-forming rocks and their granulometry composition. The increase in silicium oxide 2 in soils and soil-forming rocks is associated with the enrichment of those rocks with quartz in the course of weathering, with the redeposition of weathering products, via sorting, and also as a result of the formation of secondary quartz from silica that fizzle during weathering. In sandy soil, in the bright light granulometry composition, up to 90% of silica is contained. In loam and clay soils, it's almost reduced to 50–70%, but the content of aluminum 2 oxide 3, iron 2 oxide 3, and other oxides increases. Associated silica and losing rock is always less than in the igneous rocks. It is partially washed out during weathering, but the accumulate Ie3 as less mobile. The less of bound silicium oxide 2 and the accumulation of I2 oxide 3 are well illustrated by the calculation of the molecular ratios of silica oxide 2 R2 oxide 3. The most mobility in the profile of soils backships south, while their solubility is greater, the smaller the balance of the ions formed. Therefore, the average content of bases in loose rocks is lower than in the lithosphere. In conditions of a moist climate, loose rocks is generally depleted in bases, whereas under dry conditions, the ground accumulates. According to the content of alkaline carbon and the alkaline bases, the soil-forming rocks is divided into saline, carbonate, and leachate. According to Antipov-Karatayev, leached rocks contain up to 2% of each of the oxides, calcium, manganese, natrium, kali. Carbonate rocks contain significant amounts of calcium, CO3, up to 15-20%. In saline rocks, along with the carbonate, there are many sulfates and fluorides of calcium, magnesium, and sodium. The chemical composition of soil and soil-forming rocks to a certain extent reflects their granulometric and mineralogical composition. Sandy rocks rich in quartz contain more silica. The heavier the mechanical composition of the rock, the more finely dispersed particles there are, more than 1.5 oxides. Soil inherits the geochemical features of the original material. If the soil-forming rocks are rich in silica, then accordingly there will be a lot of it in the soil formed on them. Soils formed on carbonate rocks in the bracket loess like loam are usually rich in calcium. Saline soil forming rocks are a source of soil salinization. However, the soil forming process introduced serious changes in the chemical composition of soil. Each type of soil occurs a characteristic differentiation on the horizon with a certain chemical composition. In comparison with the soil-forming rock, the upper horizon of third-hydrolic soils is enriched in silica and contains less oxides of aluminum and iron. For Chernozem, approximately the same chemical composition throughout the profile with characteristics. Coral soils, unlike rocks, accumulate of organic matter in the upper horizon as well as phosphorus, nitrogen, and potassium as characteristics, which is a distinctive feature of soil. The nature and the extent of change in the chemical composition of soil and soil-forming rocks are in accordance with the natural factors of soil formation. The chemical composition of soil is constantly changing in accordance with the continuity of the processes of weathering and soil formation. Forms of compounds of chemical elements. Oxygen is a part of most primary and secondary minerals. It is one of the main elements of organic destruction in the water, substances and water. Silicon. The most common silicon compound is quartz, resistant of weathering. Silicon is also a part of silicates. When minerals of the silicate class are destroyed, the silica turns into a solution in the form of ortho in the bracket silicon oxide 4 and the metasilicon in the bracket silicon oxide 3 two anions, sodium silicates, potassium, and partially soil. Integrating with bases sq oxidize through the dissolved and the colloidal silica form secondary silicates. Nitrogen is an extremely important chemical element for plant life. It is part of all protein substances. It is contained in the chlorophyll, nucleus, acid, and many other organic substances of a living cell. The bulk of nitrogen is directly dependent on the content of organic matter in the soil, primarily humus. In the humus, 1/20, 1/22 part is nitrogen. Soil forming rocks contain nitrogen in very small amounts. The accumulation of nitrogen in the soil is associated with its biological accumulation from the atmosphere. Nitrogen is available to plants mainly in the form of mineral compound ammonium nitrates which are released upon decomposition of organic substances. Nitrate is an intermediate product of decomposition is practically not contained in the soil. Ammonium and nitrogen are main forms of nitrogen the plant feeds on. Phosphorus is a part of many organic substances without which the vital activity of plant is impossible. Despite the fact that plant contain P2 oxide 0.5%, pure dry mud plants cannot develop without phosphorus. Absorbed from the soil profile by plants, phosphorus is biologically accumulated in the upper horizon of soils. Thus its gross content in chernobyl reaches 0.35% or more. Sulfur is a part of protein substance in essential oil. The need of plant in sulfur are less than that of phosphorus. The biological accumulation of sulfur in soil depends on the condition of soil formation. The total sulfur content in the upper humus horizon of the soil varies widely from 2% or more. Potassium carries out important physiological function and the living organism. It is consumed by plants in large quantity, especially potatoes, root crops, herbs. The gross content of potassium in the to oxide in soils is generally high. On soils of heavy granulometric composition, its amount is from 2% or more, and in soil of light granulometric composition, much less. Calcium and magnesium are essential elements for plant nutrition. Thus, well as potassium have an important physiological role. Magnesium is part of chlorophyll and the calcium of the great importance in the creation in the soil of plant friendly physical, chemical and physicochemical properties of the soil. Many elements are contained in soil in small amounts. In the bracket less n multiplied 10 minus 3% and constitute a special group of trace elements. This includes boron, in the bracket B, manganese, in the bracket Mn, No, NO, cuprum, zinc, cobalt. Boron in plants participate in the formation of complex compounds with carbohydrates, alcohols, and other substances, accelerates the synthesis of protein. With its lack in the soil, the ovaries fall, a void appears, the yield of seed decreases. Manganese in the plant participates in oxidation reduction process. With this lack of plant organism, chemical reactions are slowed down and consequently the synthesis of organic substances plant become with chlorosis. The peat, bog and the sandy soil is the most poor in manganese. The crustaceans are very rich. Molybdenum in plant is very small, 1,000 of a percent. It is of great importance in the fixation of nitrogen by azotobacter and in synthesis of protein by the plant. If there is a lack of soil in the cauliflower and developed heads are formed, a yellow spot appears in the citrus fruits. Kappa delays the again of the river. With a lack of soil, the plant suffers from chlorosis. The tips of the leaves are white. The plant is pasty. Zinc is in most soil is in sufficient quantity. With it lack in the soil, the growth and development of plants is delayed, and the chlorotic spots appear on the leaves. Blossoming plants often do not form ovaries. Cobalt in plants is very small, in the bracket 0.01, 0.6 milligram percent 1 kilogram of dry matter. Insufficient content in the plant causes disease of animals. Thank you for attention.